What if one of the strangest ideas in science fiction was actually hidden inside the equations of physics? What if traveling to the past wasn't completely impossible? Imagine receiving a phone call from yourself, from the future. Imagine opening a door today and stepping out yesterday. It sounds absurd. It sounds like the plot of a Hollywood blockbuster. But in 1988, three physicists published a scientific paper suggesting that such a possibility might not violate the known laws of physics. And the most surprising part, one of those physicists was Kip Thorne, a Nobel Prize winner, a world-renowned expert in Einstein's theory of relativity. The paper carried a remarkable implication. If wormholes can exist, they may be transformed into time machines. To understand how scientists arrived at such a bizarre conclusion, we first need to understand how our universe works. More than a century ago, in 1915, Albert Einstein introduced one of the most revolutionary ideas in human history: general relativity. Before Einstein, space and time were thought to be separate, fixed, unchanging. The universe was seen as a giant stage where events simply happened. Einstein changed everything. According to him, space and time are woven together into a single fabric known as space-time. Imagine a giant invisible sheet stretching across the universe. Every star, every planet, every galaxy bends and distorts that sheet. The greater the mass, the greater the distortion. Gravity is not simply a force pulling objects together. It is the result of objects following the curves in space-time itself. This idea was so successful that it continues to explain everything from planetary motion to black holes. But hidden deep within Einstein's equations were possibilities that seemed almost impossible to believe. One of them was the wormhole. A wormhole is often described as a tunnel through space-time, a shortcut connecting distant regions of the universe. To visualize it, imagine a sheet of paper. An ant wants to travel from one corner to the other. The journey is long, but if you fold the paper, bringing both corners together, a tiny tunnel suddenly creates a shortcut. The distance almost vanishes. That is the basic concept of a wormhole, a bridge connecting two distant locations through a hidden pathway. The idea sounds incredible, but there was a major problem. Most theoretical wormholes appeared to be unstable. The moment one formed, it would collapse instantly. Anything attempting to pass through would be crushed. For decades, scientists believed traversable wormholes were impossible. Then came the paper published in 1988. Michael Morris, Uwe Yurtsever, and Kip Thorne. They began asking a different question. What if a wormhole could somehow be held open? The equations suggested it might be possible, but only under extraordinary circumstances. The wormhole would require something incredibly strange, something unlike any ordinary matter we know, something physicists call exotic matter. And exotic matter would possess a shocking property: negative energy. At first glance, this sounds impossible. Everything we encounter in everyday life possesses positive energy. Negative energy sounds like science fiction. Yet quantum physics suggests that under certain conditions, tiny amounts of negative energy may actually exist. Phenomena such as the Casimir effect hint at this possibility. The quantities involved are incredibly small, but the concept itself is real. And if enough negative energy could somehow be accumulated, a wormhole might remain open. And this is where the story takes an unexpected turn, because the researchers realized something extraordinary. A stable wormhole could do more than shorten distances. It could connect different moments in time. To understand why, we need to talk about time itself. One of the strangest predictions of Einstein's relativity is something called time dilation. Time does not flow equally for everyone. The faster you move, the slower time passes for you relative to someone standing still. This is not speculation. It has been experimentally verified countless times. Atomic clocks placed aboard aircraft measure it. Satellites rely on it. Even astronauts experience it. The difference is tiny, but it is real. Imagine two identical clocks. One remains on Earth. The other travels at enormous speed through space. When the traveling clock returns, less time has passed for it. It has effectively moved into the future. In a sense, time travel to the future is already allowed by physics. Now imagine a wormhole with two entrances. We'll call them Mouth A and Mouth B. Both remain connected through the same tunnel. Now suppose Mouth B is accelerated to a speed close to the speed of light. Years pass. Eventually, it returns. Due to time dilation, less time has passed for Mouth B than for Mouth A. The two mouths are still connected, but they are no longer synchronized in time. And that changes everything. A traveler entering one mouth could emerge from the other at a different point in time. Depending on the configuration, they might emerge before they entered. In other words, they could travel into the past. The implications are difficult to comprehend, because once time travel becomes possible, paradoxes begin to appear. The most famous is known as the grandfather paradox. Imagine traveling to the past and preventing your grandparents from meeting. Your parents would never be born, and if your parents were never born, you would never exist. But if you never existed, who traveled back in time? The paradox appears impossible to resolve, and it is only one of many. Could you prevent the invention of the time machine itself? Could you warn yourself about future events? Could information exist without ever being created? These questions continue to challenge physicists and philosophers alike. Some researchers believe the universe would somehow prevent such contradictions. Others suggest that altering the past would create branching timelines, entirely new realities, parallel universes, different versions of history. Stephen Hawking proposed another possibility, a concept known as chronology protection. Hawking suspected that the laws of nature might contain a hidden safeguard, a mechanism preventing time machines from ever functioning. According to this idea, quantum effects would become so intense that the wormhole would destroy itself before paradoxes could occur. To this day, nobody knows if Hawking was correct, and nobody has proven he was wrong. So where does that leave us? Do wormholes actually exist? The honest answer is simple. We don't know. No wormhole has ever been directly observed. No telescope has discovered one. No experiment has confirmed their existence. For now, wormholes remain mathematical solutions hidden within Einstein's equations. Possible on paper, unconfirmed in reality. And even if wormholes do exist, we have no evidence that exotic matter exists in the required quantities. We don't know whether such structures could be built, maintained, or traversed safely. The engineering challenges would be beyond anything humanity has ever attempted. Yet the possibility remains, and that is what makes this story so fascinating. The idea did not emerge from a science fiction novel. It emerged from serious scientific research, published in one of the world's most respected physics journals, written by scientists whose careers were built on rigorous mathematics. They did not claim to have created a time machine. They did not claim time travelers exist. But they demonstrated something remarkable. The known laws of physics do not completely rule it out. Perhaps time is far stranger than we imagine. Perhaps past, present, and future are connected in ways we do not yet understand. Perhaps the universe contains hidden pathways stretching not only across space, but across history itself. Maybe somewhere in the vastness of the cosmos, a natural wormhole already exists, waiting, silent, connecting distant moments in time. Or perhaps the universe has built-in rules that forever prevent such journeys. We simply do not know. But one question remains, a question that has puzzled scientists for decades. If time travel to the past is truly possible, where are the travelers from the future?